Hello everyone. In this video, we'll discuss the first chapter of Daly's Econometrics textbook. That is, so chapter 1 is about the quest for causality. Now, causality is the central theme in any econometric exercise because most of the econometric tools help us to establish causality. Now, we'll see later on whether we are able to actually establish causality or not, but that's the starting objective. So basically, all econometric tools help us to answer important questions such as, so one of the question in econometric exercise could be, do anti-poverty programs work? Do anti-poverty programs work? So here we are trying to establish a causal link between anti-poverty programs. So between a anti-poverty program, let's say NREGA, and we want to see whether it has an impact on raising people's standard of living. So we want to establish a causal link between an anti-poverty program such as NREGA on people's standard of living. Another example could be, does unemployment affect inflation? So here we want to see the existence of a causal link from unemployment to inflation. Third, does campaign spending affect election outcomes? So these are some of the questions that we wish to answer through the tools of econometrics. Now, in all these questions, as you can see, we are basically trying to establish a causal link from one variable to the other variable. Okay, so that's basically the objective of econometrics, to help us establish causality. So basically, how do we know what we know? It's a simple question if I ask, how do we know what we know? So suppose we know that sugar and salt, excess sugar and salt are bad for health, but how do you know that? Or why do we think what we think? Why do we think what we think? Why do we think that sugar is bad for health? Why do we think that alcohol is bad for our liver? So the modern answer to this is, so the modern answer is evidence. So in order to convince others and in order to convince ourselves, we need to provide information that others can verify. Okay, if we want to say that alcohol is bad for health, then you need to present evidence, yes, to convince others and to convince you that actually it is bad for health. It cannot be your assumption. It cannot be. It cannot be a thing that you are assuming to be true. It has to be backed by. So the modern answer to this is that it has to be backed by evidence. So what is evidence? So in order to convince others And in order to convince ourselves, we need to provide information that others can verify. So that information is the evidence. Okay. The next question arises, what is the basis of our evidence? What is the basis of our evidence? The answer to this is, now in some cases, we can see cause and effect directly. For instance, if you see a person being hit by a car and the person dying due to that accident, then you can attribute that person's death to that accident. So in this case, since you were there on the when that incident happened. So in that case, you can establish a cause and effect relationship that the cause for the person's death was because of the accident. Okay, so in some cases we can see cause and effect directly. So for example, we see a person getting hit by the car and dying on the spot. So in this case, as per your perspective or as per your observation, you can see that the accident was the cause and the effect was the person's death. But in most cases, the evidence is not directly observable and we have to trace back a chain of causality. So in most cases, the evidence that a particular thing happened is not directly observable, the evidence to support that thing, and we have to trace back a chain of causality. So we have to think of potential factors, causal factors that would have led to that outcome. Okay, so for example, if I want to ask, why did Donald Trump win the election in 2016? So that's not directly observable. I'll have to unearth the set of factors that could help me explain why did Donald Trump win the election in 2016. Why has, another example could be, why has crime increased in Delhi in the recent years? So this is another question that we wish to answer, and again you'll have to trace back a chain of causal events that could help to explain why has crime increased in Delhi in the recent years. Now, in these cases, there is no way of directly observing cause and effect. You cannot directly observe cause and effect here. So in this case, we then turn to data. Okay. So in order to answer these kind of questions, obviously, since you can't directly attribute these events to just one set of factors. Why did Donald Trump win the election in 2016? There could be a multitude of factors and not just one factor. Why has crime increased in Delhi in the recent years? Again, there could be a host of factors which cannot be attributed to a single factor. So in all these cases, we base our analysis on data, or which is evidence or information. So to give you an example, let's say a building collapses during an earthquake. Okay, now what we wish to answer is, why did only this building collapsed during the earthquake and not others in the same city? So, what factors led to the collapse of only this building and not others in the same city during the earthquake? So that's a cause and effect type of question that we want to answer. What led to the collapse of only this building during that earthquake? Now, factors could be, let's say, suppose possible factors could be the height of the building, that it, let's say it was longer than other buildings in the city. It could be the design of the building. It could be the age of the building. It might be an older building. It could also be due to the fact that its location was near the earthquake's epicenter. So how do we establish this fact? So how do we establish a cause and effect relationship in this case? So we can collect data in order to unravel the causality here. We can collect data on buildings that did and did not collapse. Okay, so although we were trying to answer that causality question for a particular building, but it's not the case that during that earthquake only that particular building fell or collapsed. So there were certain buildings which fell during the earthquake, certain buildings which did not fall during the earthquake, and we wish to answer why did the buildings which fall during the earthquake, and why did others sustain the earthquake. Now, if Now, based on this data, let's say, suppose, suppose we find that older buildings were more likely to collapse. So our data suggests that the buildings which were older in our data set, they were the buildings that actually that collapsed during the earthquake, and the others survived. So based on this, we might conclude that age is a key factor that determines a building's ability to withstand an earthquake. So that's one observation, or basically an inference that we can make. Now suppose our data suggests that suppose the data suggests that it is in fact that buildings constructed without steel reinforcement collapsed no matter what their age. So instead of the data suggesting that it was the older buildings that collapsed during the earthquake, suppose our data suggests that buildings constructed without steel reinforcement collapsed no matter what their age. So in this case, our conclusion then, our inference would be buildings without reinforcement designs were more likely to collapse. So in first case, our inference what would be that it was actually age. That's a key factor that determines a building's ability to withstand an earthquake. While in the second case, the inference is that buildings without reinforcement designs are more likely to collapse during an earthquake. But in both the cases, we have to understand a very key factor that's a central issue or a theme in causality studies or in econometrics, that is correlation is not equal to causation. Now this is something that you should always remember, and you should always analyze in any causality or econometric problem, that correlation does not necessarily imply causation. So to give you an example, now let's say in the first case, so in the first case we had inferred that old buildings, in the first case the inference was that old buildings were more likely to collapse. But we cannot say for, so this basically leads us to the conclusion that age is a key factor that determines a building's ability to withstand an earthquake. But we cannot, we can't say with certainty that age of a building, that age of the building is the main explanation for the collapse. The reason being, so that was an observation, that was an initial inference that we made, but if you think about it, you cannot say with certainty that age of the building is the main explanation for the collapse. Reason being, the reason is it could be the case that more buildings from a certain area that more buildings from a certain area were designed a certain way. So what this basically means is, so it could be the case that the buildings that actually collapsed during the earthquake were from a particular area and were built around the same time when a particular technology was being used, and it was actually the technology or the design that that was faulty and that led to the building's collapse and not actually the age. Okay, so just making a simple conclusion that age was the factor that older buildings actually find it difficult to survive during an earthquake may not hold true. It could be the fact that these buildings, which were built around the same time, let's say they were all built around 25, 30 years, 50 years before, so that makes them older compared to other buildings. So, and they actually collapsed during the earthquake. It does not mean that that age was the cause. That they are, since they are 50 years older, that's why they collapsed. It could be the case that since they were all built using a certain technology or a certain design that was prevalent at that time, and that did not help these buildings withstand the pressure of the earthquake, and hence they collapse. So it was not actually age. So we are talking about possible factors that could have contributed to the collapse of these buildings. So just to say that age was the single factor that led to their collapse may not. So I'm using the terms may not here because we are not dealing with data right now. We are thinking of possible uh, causal factors that could have contributed to the building's decline. Now, again, another related thing here could be that it could be that there were more old buildings in a neighborhood where the seismic activity was most severe. So Another point could be that the older buildings that we actually find were the ones who collapsed during the earthquake could all have been located in a neighborhood where the seismic activity was more severe. That means they were more closer to the earthquake's epicenter. So in this case, even though our data, just by looking at the data, if we find that it was actually older buildings that collapsed during the earthquake, we can still not conclude that it was the building's age that led to their collapse. It could also be due to the fact that these buildings coincidentally were near the earthquake's epicenter, and hence the severity of the earthquake was more in these areas that actually led to the building's collapse. Okay, so basically, in all these cases, just looking at data and making a conclusion that age is a cause for collapse, or steel reinforcement is a cause for collapse. So these are, you cannot directly attribute these factors as reasons behind the building's collapse. You cannot direct, because you might find that there is a correlation between older building and the buildings that collapsed, or correlation between buildings having steel reinforcement and they did not collapsing during the earthquake. But this correlation, so there might be correlation, but this does not necessarily imply causation. This does not necessarily, so I'm using the word necessarily here, they might imply causation. So we'll have to employ various tools to get to that causation. But just looking at the correlation does not mean that it was also a causal factor. It could also be the case that the fact that old buildings collapsed was a massive coincidence. Okay, it might not be that they were closer to the epicenter. It might not be because of their age. It could also be a coincidence. We have so many incidents of coincidence in our daily lives. Okay, so all of these basically reinforce the idea that you might have correlation between two variables, but that does not imply causation. Okay, so another thing that you can note down here is that older buildings collapsing might also be a major coincidence. Okay, so a fundamental starting point in any serious data analysis, again, I'll write that correlation does not imply causation. So if correlation is not causation, then what does imply causation? So the question now is that if correlation is not causation, then what does imply causation? So this is a key question that we will look to answer. So this is our key question, and it would take a whole set of topics to unravel this question, that what basically helps us to imply causation. So the answer to this is, without getting into the details, because this is something that we'll explore in subsequent videos, if we can find if we can find exogenous variation, if we can find exogenous variation, then correlation is probably causation. Now, what do we mean by exogenous variation? This is something that we'll explore in subsequent videos, but at this stage, let us understand this through the same age and building collapsing example. So, if we are able to basically find out that it was actually just the impact of age that led to the building's collapse, and other factors did not have a role to play. So, age is the only exogenous factor that helps explain a building's collapse. Then, obviously, in that case, we can say that age is probably a causal factor that leads to a collapse. But exogenous basically means that it is only due to the impact of that single variable. Okay. So our task will be to figure out what exogenous variation means and how to distinguish randomness from causality as best as we can. So our task in this econometric exercise is to figure out what this exogenous variation means, how do you basically establish exogenous variation, and how we can distinguish randomness from causality. So basically, uh, in the building collapse example, so we want to establish causality. We want to find out the causal factors behind the building's collapse. We do not want to be in a situation where the factors which we think are random, like we are unsure of the factors that led to the building's collapse. We want to, as far as possible, get to the best causal factors that we are able to explain. We do not want them to be attributable to random reasons. Okay. Now, in this whole econometric exercise, we will look at core issues. Three core issues that we need to address or learn here. One is randomness, which I just explained. So first is randomness, which basically means sometimes the luck of the draw will lead to observe will lead us to observe relationships that aren't real. Other times, random chance will lead us to miss relationships that are real. Now, this is a very important point. Now, so what does randomness basically means that sometimes we could be now because of randomness, we could have a data where it was a coincidence that only uh, that the data we had only in that data they were only older buildings and that actually collapsed during the earthquake. Okay, so if you could have opted for a larger sample or if we could have a different sample, we could have also observed buildings of different ages collapsing during the sample. But it could be a coincidence that we were unlucky that we had a data set in which they were only older buildings and and those collapsed during the earthquake. Okay, so in that case, we might falsely conclude that it was age that led to the earthquake. So that's the randomness here because we randomly selected a sample. Other times, it could also be the case that we could miss relationships that are real. The data could be such that, or the sample could be such that we could have drawn certain causal conclusions, but we couldn't because the data was in that shape because the data was so collected. So randomness could be both ways. It could help. It could lead us to make falsely false conclusions about causality, or it could about a causal link, or it could lead us to make false conclusions about the absence of a causal link also. So both ways it's true. The second important theme that we will explore is endogeneity. That's a very important theme that it's a phenomenon that can cause us to wrongly think a variable causes some effect when it doesn't. Okay. And the third thing that we would look in the subsequent videos is randomized experiments, which have become popular in the last few years. Randomized experiments. Economists Abhijit Banerjee and Esther Duflo actually won the Nobel Prize for their work on randomized controlled trials. Now, these randomized experiments, they are considered to be the ideal way to overcome endogeneity. However, usually these experiments are not possible, and even when they are, things can go wrong. So in the subsequent videos, we'll try to address all these three issues: randomness, endogeneity, and randomized experiments. And we'll see how these three issues are central to a cause and effect problem that we try to unravel in econometrics.